Alright, welcome back students, and now we're going into physics of the atom. Alright, so we're starting off with electrons um, and the role it plays in the atom. As you know, everything is made up of matter. Matter is made up of atoms. So therefore, atoms are very important, and they contain three particles, which are the electron, the proton, and the neutron, and that's what we're going to investigate and observe and read about today. We're also going to figure out how the heck did they come up with atoms. Okay, we're going to discover that, and we're going to put bookwork into real life activity in terms of we can relate it to real life. Okay, so first of all, we start off with electrons. Today, our idea of matter revolves around the presence of atoms, which is true. I am made of atoms and you are made of atoms. The book you have is made of atoms. The computer you're using is also made of atoms. Owing to this, we define matter as being made up of atoms. And I have a beautiful picture here of, well, it's a schematic of the atom, where we have the protons and the neutrons inside of the nucleus and the electron orbiting that nucleus, pretty much like our solar system. Now, electrons are very tiny particles that you cannot see with your naked eye. However, you can see them with an electron microscope, as can be seen in the picture here. It's huge. It costs millions. Okay. Our referral to the atom, its parts, and its involvement in science may be credited to scientists such as Democritus, Thomson, Rutherford, Bohr, and Chadwick. Okay, so we have 5 scientists that contributed to what we know or refer to as the atom today. And we have to thank them. Yay! Right? Okay, so in about 400 BC, we're starting off with the Greeks, okay? In about 400 BC, there was a Greek philosopher by the name of Democritus, and he suggested that matter consisted of very small particles that couldn't be chopped up any further. So those were the smallest particles, he then said, that were known to man, okay? And he called these particles atomos, from the Greek word indivisible. Then along came J.J. Thomson with his plum pudding model theory. And this was in 1897, where he discovered that heating metals could release small electrons. And he called them small particles, and he referred it to the word electrons. And he proposed that the electrons were released from inside of the atom. So therefore, how could the atom be the smallest particle known to man, right? So that's what he did. He went and basically refuted Democritus' claim that the atom was the smallest particle. But you know, Democritus, we still have to clap him because he came up with this idea of atoms. And so what J.J. Thomson went on to say is that yes, atoms exist, but they are not the smallest particle known to man if electrons come from them, right? He also realized that electrons were charged particles, meaning that they either had a positive charge or a negative charge, since they could be deflected by a magnetic or an electric field. He then proposed a model where electrons in an atom were trapped inside a positively charged sponge. You're going to see that up here, where he said, oh, well, you know, we have an atom, and in that atom we have positive charges and negative charges. And so he called it like a model, a plum pudding model. He referred to it as a sponge. So this is also known as and it's right up there, the plum pudding model. I just put this dash here to see if you're paying attention. Now, we had Democritus, we had Rutherford, we had Democritus, we had Thomson, and then up came Rutherford. And Rutherford now was like, yeah, I know we have something called the atom, and yeah, I know we have something called the electrons, but you know what I'm going to do? I'm going to prove to you that there is something else in there called the nucleus, right? Because we need to explain how the atom exists. I mean, if the atom is there and we have electrons, what's balancing it out? There must be something balancing out a charge, right? Because atoms are actually neutral bodies. So if we only know that the atom exists and that electrons exist, and then basically saying back in the day that the atom was negatively charged, whence we know that atoms are actually neutral bodies. So in 1911, Ernest Rutherford proposed that most of the atom was empty space and that it contained a nucleus of very concentrated positive charge. You see that? So where there is a negative charge, there must be a positive charge to make something neutral, right? It must balance out or pan out. He suggested that small negatively charged particles exist in a surrounding electron cloud. So here we go again. Now we're refuting Thomson, because remember Thomson was saying that there was an atom, and in the atom was actually entirely positive, and these electrons actually were attracted to these positive charges by being in the same place as these positive charges. And what Rutherford is saying is that no, the positive charges are present, however, the electrons are not in the same area as positive charges that exist in this cloud that surrounds it, right? And then therefore it will make the net charge zero. And a few years later, Ernest Rutherford asked two of his students, Hans Geiger and Ernest Marsden, to investigate the structure of an atom. And what did he do? How did he do that? Basically, he used an, what do we call it again? He used a source that could give off radiation. He used an alpha source that could give off radiation. And what he did, he put a gold foil, a very thin leaf of gold foil in front of this radiation. And what he found was that some of the rays actually passed directly through the gold foil, while some of the rays were deflected, or some of them just, they hit and came straight back. So deflected meaning they went at some kind of angle, but some of the particles went, they hit and they came back straight on the line that they were traveling on. So he found that, just like what I said earlier, that some of the particles went straight through. You see that here? It went straight through the gold foil. So this represents the gold foil, and these over here represent the alpha particles. And then some of them were deflected, like a small deflection, right? And then some of them just came straight back. So that suggested that there was a dense body somewhere inside of the atom. Not only that, this suggests that the atom was surrounded with a lot of space. Because how would it be that alpha radiation would be able to pass through the gold foil? So he realized that space must be around there, around the nucleus. So in other words, Rutherford was basically coming up with the orientation of the particles inside of the atom. So since his findings could not be explained by J.J. Thomson's Plum pudding theory, Rutherford's team determined that since most of the alpha particles pass straight through the gold foil, most of the atom must be composed of empty space, which is what I mentioned earlier. He also determined that some of the alpha particles, once they were deflected, they must have been repelled by a dense positively charged part of the atom, later named the nucleus. And this nucleus would have contained nucleons, what we want to say is the neutrons and the protons. And this mass in the center is what contributes to the entire mass of an atom. Okay? So that was it. And then he also, the apparent radius of the atoms was much greater than the measured size of the nucleus. So the atom is like the solar system, like if you could think of the sun and all the planets orbiting the sun, right? You could think of an atom as a nucleus being the sun, and the electrons being the other planets, like Mars, Venus, Mercury, Earth. So we could envision that if you learn about the universe. Then here comes Bohr, very brilliant man, who says, yeah, we know the electrons are not inside of the nucleus, but we have to account for where they actually are. And so he figured out that these electrons must be existing in some type of spatial arrangement where you have levels to this. It's like levels to this, you know. You got level 1 where you honk your car your horn nicely, and you have level 2 and you get, you know, like toot toot. You're just like, oh my god, these people won't hurry up. So we put the electrons in levels, and so he suggested that the negatively charged electrons which orbit the nucleus must be particular shells. So that's what he called the levels. The energy levels were shells, right? And so we have each shell being able to hold a maximum amount of electrons. And we'll get to that when we move on further. He further suggested that a unique energy level was required by an electron to exist within any shell. And all previous models of the atom could not explain the behavior of the electrons and why they did not fall into the nucleus due to electromagnetic forces. So in 1932, here comes Chadwick, who discovered neutrons, which was the uncharged particle present within the nucleus. And they coexisted within the nucleus with protons. Neutrons were difficult to detect because, unlike protons, which are positive, and electrons, which are negative, they didn't have any charge, and therefore they were not affected by electric or magnetic fields. Okay, so now you know how we came about with the idea that atoms exist and that matter is made up of atoms. We also know how they devised the way an atom would have existed, right? So those scientists and their studies gave rise to what we now know as today as the atom. So we're going to do a little recap. Matter is made up of atoms. Everything is made up of matter. Atoms cannot be seen with the naked eye, however can be viewed using an electron microscope. Democritus suggested that matter is made up of atoms and that atoms were the smallest particles known to man. Thomson suggested that the atoms were not the smallest particles known to man, since electrons could be emitted from them, and Rutherford suggested the presence of a nucleus. Then we had Bohr, who came along and suggested that the electrons orbited the nucleus in electron shells, and then we had Chadwick, who suggested that there were neutrons within the nucleus. And here ended part 1 of Physics and the Atom. See you soon.